Kia ora tātou, it's Bill here. What I want to do is I want to have a look at the addition of a FET to act as an intermediary switching device between the microcontroller and some other load. So for instance, having a look at the video here, what I've got is I've got some of these cheap LEDs. They come in packets of like, I don't know, 100 or something like that, all wired together in parallel. So what we've got there is we've got a number of LEDs. They're all in parallel. So they're like this. And each one, and there's lots of them. And so what we do is we're going to connect this to some intermediary device. I'll call it a FET, and use our microcontroller to turn it on and off. And you can see in the breadboard here that I've got this device. This is a little logic MOSFET. So it will switch at logic levels. Typically FETs switch at around 10 volts, but these logic level MOSFETs are designed to switch at lower voltages, like about 2 volts or so. There's a couple of resistors here which are part of the circuit, and it's being driven, if you have a look in this diagram, in the simulator, it's being driven by D3. And now the reason we need this FET is because if I put all these LEDs onto one of the output pins of my microcontroller, it can only, at max, a single pin can drive about 40 milliamps. And this here will require a lot more than that. Probably, I think I measured it around about 150 or 200 milliamps, something like that. So that's too much. So I need this FET to do the switch. And I've explained that in the notes how it works. If you come over to the simulator here, you can see how this is wired up. I explain the resistors in the notes, and there's the actual layout diagram. Now, really important, if you're going to be switching anything that's inductive at all, you need this flywheel or flyback protection diode in the circuit. Now, the reason we use a FET is because of high currents, but of course, if you try and switch a very high current device using a breadboard, these little fine contacts inside the breadboard tend to heat up, and that melts your breadboard. So really, if you're going to be driving something which is higher current than what you should really with a breadboard, then you want to be using, first of all, a bigger FET. You know, this little BS170 can switch up to about 0.5 amp, and some bigger FETs, of course, like this one, can switch up to about 60 amps. But you still can't stick one of these into your breadboard because all that high current through these contacts will just melt your breadboard. Okay, so what you would end up doing is you would end up connecting this in some other way. Now you can actually buy these little boards here, which have got the FET on them and the pins to plug into your breadboard, and then it's got a separate power supply. Okay, so they're quite a useful thing. So that means that you might have some other power supply here, like you might have 12 volts, and this might be a 5 amp load. And so all you have to do is connect your FET. You have to make sure your grounds are connected. Okay, and then your load can be like a high current, higher voltage load. In fact, most of these sort of FETs can switch up to, you know, 60 volts. Even this little BS170 runs up to about 60 volts. But this, of course, can switch like 20, 30, 60 amps, depending on the FET that you buy. So that's what we're doing. We've got these little cheap LEDs, and we're going to drive those with this FET. I think that we'll just stop briefly at this one, and then we'll go on and do another video. Cheers.